All right, so in chapter 4, we're going to start chapter 4, but only do the first two sections. Then we're going to jump into chapter 5, and then later in the term, we'll come back to chapter 4 and finish it out. So when evaluating analytical data, we want a few tools from statistical analysis to help us out. So there's 3 considerations about experimental error that we should be familiar with. So before beginning an analysis, we need to consider the errors that are associated with each measurement and how those errors are going to affect the utility of our methodology in making our measurement. Do they have a cumulative effect? The second one focuses on the measurement process during the analysis. So we need to make sure that we're monitoring that and make sure that it remains under control. And finally, at the end of the analysis, the quality of the measurement is going to be evaluated and compared with the original design criteria. So let's think about this using the mass of a penny as an example. So what considerations would we want to take into account if we were going to take samples and try to determine the average mass of a penny? So first, the problem is too broad, so we have to refine the question. Many countries have pennies, so we're going to restrict our analysis to the pennies that are minted in the United States. So the second consideration that bounces from that then is that pennies are minted at multiple locations. Will this affect their mass? Should we choose to just use one location that is minting pennies and get the average mass there? Or can we ignore that? So we're going to ignore this fact for the moment or the time being, but we can come back to it if we find that there is a large deviation in the masses. The third thing that we need to think about, do we want to use new or older pennies? How has the processing of the penny changed over time? Does it make a difference in the mass? So this answer is not so obvious and would require us to do more research. So for our sake, for our example, we'll narrow the question to what is the mass of an average United States penny that's currently in circulation. So in this case, we've taken the mass of 7 pennies to be our pool that we're going to look at as our population. And we can do first 2 analysis. We can look at the mean and we can look at the median. So the mean is the numerical average that's obtained by adding all the sum of our samples. So this sign here is the summation sign from the initial to the final. And then we're going to divide that by the total number of samples, and that gives us our mean. So what is the mean of this sample set? Go ahead and stop the video for a second and calculate the mean. The mean that I calculated is 3.117. So hopefully that's what you got as well. The next one is the median. The median is the middle value where the data are ordered from the smallest to the largest. So that's what we'd have to do with this data set. So when the data includes an odd number of measurements, the median is going to be the middle value. So if we have the even number of measurements, we take the 2 in the center, add them together, and divide it by 2. So here, what is the median? Go ahead and do this problem as well. All right, so we'll note that this one is the only one that's out of order. We would put this one back at the beginning, and then we would find the answer that's in the middle, which would be the 4th place. So in this case, if we put this up at the top, we'd have 1, 2, 3, 4. So 3.107 in this case would be the median answer in this set. It would be the 4th one. So this is an odd set. All right, so if this data set only had 6 values in here, that would be 6 divided by 2 is 3, and 6 divided by 2 plus 1 would be 4. So we would have to add up samples 3 and 4 and divide it by 2 to get the actual median in that data set. So like if we blocked out this last one, cross off 7, and then move that one up to the beginning, we would have 1, 2, 3.094 would be number 3, 3.107 would be number 4. We would add these two together and then divide it by 2, and that would be our median answer. So the mean and the median are important components of looking at our values that we have, but they don't tell us enough. We also need the measures of spread as well. And so this looks at the variability within the samples or the spread around the samples that we've got. So we can do this with 3 common measures of spread. This is going to be the range, the standard deviation, or the variance. So let's take a look at these 3 components as well. So the range, which is indicated by this lowercase w symbol, is the difference between the largest and the smallest values in the data set, right? So for our penny range, this would be 3.198 minus the 3.056, and this would give us 0.142 grams. So this would be the range of our data set. So this helps provide some information about the total variability in the data set, but it doesn't provide any information about the distribution of individual measurements in between those two. So the standard deviation can help us with that. So standard deviation is either given by lowercase s or by the sigma. So you'll see both of these. So it describes the spread of the individual measurements about the mean, and it's given with this equation, so it's a little bit hairy to do, but you have a summation of all of your values with each individual value subtracting the mean from it and then taking the square. You have to take the square because some of these values could be negative. So you want to take the square, so when you add them all together in this summation, that you get the total variability included in there and you don't just subtract off numbers from it. This is then, the square of this summation is then going to be divided by the total number of samples that you have minus 1, unless you've sampled the entire population. If you've sampled the entire population, you can just use n. Okay, but if you've only taken a subset of the population, you want to use n minus 1 in your standard deviation calculation. And then once you've done the math in here, you're going to get rid of that squared value that you had up here by taking the square root. All right, so I would ask you to practice doing this by taking our data set that we've done here. Right, so we've got the mean at 3.117, right? So each of these values minus the mean and then square it, and then you would add them all up together. Divide that by 7 minus 1 would be 6, and then you would take the square root of that number. All right, so you are going to love Excel during this class, because Excel can do the standard deviations for you very quickly, and we'll get some practice setting that up. So the standard deviation can be presented just as the standard deviation, or it can be presented as the relative standard deviation. So this takes our value for the standard deviation and just divides it by the mean. This will give us the relative standard deviation, and that is given as the lowercase s with the r by it so that you know it's the relative one. So you can also take this as a percent by multiplying this by 100, and you can have the percent relative standard deviation as well. So we'll get some practice using that as well. So here is a practice problem. Go ahead and calculate the standard deviation, the relative standard deviation, and the percent relative standard deviation for this data set. All right, so doing that by hand is quite a chore. All right, so we're going to use Excel quite a lot to help us out. So for any column that you want to calculate the average or standard deviations from, that's going to be very easy to do in Excel spreadsheets. And our formulas for standard deviation, there's 3 of them that you can use. And that's going to be stdev.s, stdeva, and stdev. Right, so this is the most common one that we are going to use, stdev.s. This is going to calculate the standard deviation of a sample from a population. So this is the most common type of data that we're going to have. If you have the entire population sampled, you can use stdev.p as the formula. But the .p version, you have to have the entire population. That's going to correspond with the equation using just n rather than n minus 1. So the stdev.s uses the n minus 1 version of the standard deviation. So that's going to be really rare to need to use the .p version. All right, and this just gives you some definitions for the standard deviations. We're mostly going to have numerical data with the standard deviations using stdev.s. So this is the one that we will focus on. The older versions of Excel would just use stdev. All right, and that is just a little bit of introduction to some of our data analysis. We will come back to Chapter 4 and look more at propagation of error in a future lecture.